Sorry, my husband just found out that the cats ate our cookies.
That's what cats do.
So, no breakfast for us this morning. They found them on the table and they ate all of them. And I don't know how they can feel good because they were not supposed to eat that.
You know how those balls are.
Sorry, I had to share this with you because my husband just woke up and he was like, "Did you eat all of this?" Or did that?
Hello everyone, and welcome to our new episode of BioRoom. Today we're going forward with our series of discussion on science communication, and I want to start by presenting our dear friends Tahira, Anwar, and Bruno Mota. They will be chairing today's session, which is about how to prepare a Scicomm presentation. So without any other hesitation, thank you both Tahira and Bruno. We will be happy to hear you out and follow what I'm sure will be a great discussion.
Today we will be talking about Scicomm, and so we thought to start with some general tips that we could use for science communication. So please feel free to add your tips, to comment and everything. So in general, when you talk about science, you should probably consider your audience, because most often probably we talk with people that are in our field that can understand us, but it can also happen that we talk to people that are from other fields, not very familiar with what we do, or even with lay people. So considering your audience and adjusting your presentation to that is something that you should always do. Which brings us to the second point, which is make your science understandable. So always keep in mind to who you're gonna talk, and always make your slides or anything that you're using to communicate to make it as understandable as possible. Build your take-home message. So ask yourself, what is it that you want your audience to remember? What is it that you want your audience to go back home with? So think of your take-home message and build your story around that. Make a connection with your audience. So this is a bit like putting yourself in the shoe of the audience. So why should they know something? Why should they know what you're going to talk about that? What exactly should they know? And often I also was advised to use humor or something funny so that you can make a connection with your audience and engage them more. Put yourself and your audience at ease. I think that this for us scientists is very important, because maybe we often think that we are kind of in an interrogation, scared of the questions session and so on. But think not as a lecturer, don't think that you're giving a lecture, but that you're going to have maybe a dialogue with your audience. Don't be afraid to show also what went wrong. I think there is often the idea that scientists, know it all and do everything perfectly. So it's also good, I think, to show that we do make mistakes, and whatever we are showing maybe had a failure or something along the way. And then some practical tips: visualize science, use analogies and metaphors, and make it accessible as much as possible. And then limit jargon and big words, because they can a bit make you like a show-off person, but also you can lose connection with your audience if they don't understand you, and if they don't understand the words you are using. So these were some of the tips I wrote down. If we want to I don't know, comment, if somebody has something to add, that would be great.
Thank you, Tahira. I think that you touched a very important point. The first one, I think it's the one that we need as scientists to engage with the public, which is something that usually in scientific presentation, especially in conferences, we have a very tight schedule, very tight times. So we don't have the time to ask questions and then receive the feedback and go on with our presentation. So that's a type of presentation which is completely different, and for us scientists is a little bit difficult sometimes to put ourselves at the same pace with the public to see what they think or what they are receiving as
it definitely it needs thinking. You have to really to think about that, because otherwise, at least I was guilty of this kind of mistake, that I would not often think that, okay, maybe I have to kind of adjust my presentation so that it's more reachable to everybody.
Yeah, I think also great scientists, sometimes they're not able to effectively communicate their science because
Yeah.
they do not put themselves in the position of the
Yeah.
audience, like you said.
Yeah.
So that is something that is totally something that we need to adjust and to understand how to do. And the second thing that I liked a lot was, and then I'll leave the word to other people in the chat, was the fact that scientists think they know it all. And that is totally right. Sometimes, and it is also something that Bruno was making as a point when we were
Yes.
chatting about this,
Yeah.
that we should like make it more about as a scientific process. And I think Bruno will also talk about that later.
Yeah, later. Yeah.
So not as much as like we don't have all the answers. So we are looking
Exactly.
for answers, and we're gonna show people how we're looking for answers. That's
Definitely.
sometimes part of the science communication process.
I think there are a couple of things. One is a tip, the other one is like also again going back to the topic of the audience. I think that when you are a scientist, at some point you really get disconnected with the reality of what people know about science. And for instance, I can make a very easy example. So people are always talking about, for instance, the pH. You are going to buy a gel shower and they say, yeah, pH 5.5 or pH it respects the pH of the body, whatever. But later you ask people what pH and they don't know. And same thing happens with genes. Everyone is talking about genetics and all these things, but you ask them what is a gene and they don't know what is a gene. So what I mean is that we think that people know what we are talking about, but they really don't have like those concepts. So I think it's very difficult to put ourselves again to the level in which you don't know those things and you don't have any background of that type. And it's really a challenge. So I really love that you put it at the first as the first thing, because it's very, very clear to me that we have, yeah, what the protein is. That's what Leah was saying. That is totally true. They don't even know what the protein is exactly. We are working with for so many years that we lose connection with that. And I think that that's the biggest challenge we have right now. The second thing, for me, something that is very, very important also is to make it like very visual, as you're using analogies and metaphors, but also if you're preparing a presentation that is supporting you, also don't put like a lot of words. People don't like words, or they don't understand graphs. They don't care about graphs that much. They want a story. So for me, one extra tip would be like, tell them a story. Tell them like a tale, something that they want to really know, and also make them interesting for them in the sense that when you're choosing a topic, choose a topic that you think that they might care about. So I think that exercises are awesome, but probably they don't think so. So I probably need to reframe it in another way that make it interesting for them and try to find a problem that it's big for society. So that would be the other one maybe I would add. But I think that they are like really good tips.
I also think depending on the audience, it can change if they're kids or if they're adults.
Yes.
That is another thing that we should consider, because sometimes like kids are even like even more stimulating to talk to than adults, and adults sometimes you have to be careful not to offend them. So when you ask them what a protein is or what DNA is, sometimes you may have like, I don't know, a professor in the audience and he may feel offended, or a person that really reads a lot about science and he may feel offended that you ask that question. So I remember that when I took some science communication classes, a teacher once told me, never ask direct question like, do you know what that is? That can feel a little bit aggressive for the audience, and if they are adults especially. I mean, kids is fine because they will like raise their hands and say whatever they want, so they don't mind, they don't care, they don't get offended. But adults will feel like a little bit threatened, like, oh, is she testing me? Is she testing my knowledge? And in that moment, so you have to find some other subtle ways to see, perhaps you know that a protein is this and this, and then you try to engage them, I don't know, more gently. Do you have any ideas on how to do that?
Well, I think people don't like to, I mean, especially adults, don't like to look foolish, especially in front of other
Yeah.
people. So a lot of people like, sometimes they actually want to answer your questions. They have some idea what's going on, but perhaps they have a question, but they think, oh, that's going to make me look ignorant, make me look idiot. So the one thing that Tahira said, I think it's very important, that, I mean, to show that in science, you make a lot of mistakes. In science, there's a lot of things you don't know, a lot of things that people don't agree on. And when you illustrate those points, I think people are more willing to say, okay, I don't know this, so can you explain it to me, or I disagree, or whatever. So they engage it more if you don't sound like an oracle that knows everything. It's just going to pump them with your highfalutin knowledge.
Yeah,
I agree. I agree with
definitely.
that.
Yeah, like go closer to the audience, like really, like try to make a connection, think like that. So yeah, definitely.
I have a question for you both because I don't have that much experience on sign communication, honestly. How much do you think we should use humor? Because you want it to be like, you want them to understand what you're saying, it's real and it's serious, but you want to do it like fun too. You want to do that. So, what is the balance? What is your experience like about that?
I was just going to say that it has to be something that feels natural to you. So some people are more like jokey and make jokes and make like self-deprecating jokes, and some people are not like that. Some people are more like they're more inspiring the way they talk. So someone like Carl Sagan, they're very inspiring. They talk and you say, wow, that's like amazing. It's blowing my mind. This is like inspiring to become a scientist. And some other people like joking, like Feynman, and say, oh, this is like that, and like they're more they're less formal. So you have to use something that you have. So that's depending on the kind of person that you are. Now, when you're using jokes, I think that there are two purposes for a joke. One is to approximate you to the audience, so they feel like you're a human. So you tell a joke about something you did wrong or something that makes you feel more human. And the other is to approximate the audience to the subject. So it's something that may sound very abstract or something that may sound very distant from their lives, and they make a joke, an analogy, or something that make them consider that in a different perspective because it's a joke. So they are like more open to that.
Yeah, I try to, like when I was doing my PhD talks, especially if they were like maybe in the lab and stuff like that, I always put like, you know, funny faces and things like that to kind of make a connection and to make it a bit lighter as well. Like, you know, it doesn't just have to be like, you know, just graphs and just, you know, cell and just protein and so on. So I at least personally try to make it lighter with not necessarily joke, but also like with some connection to the real life and so on, some picture or something. So yeah, at least I personally do that as well.
Yeah, I think that with humor and communication, to sum it up, I will say that if you feel like it, if you just feel that this is what you will normally say to a human, then go for it. But if it's not, you know, if you have to force it and etc., I think that people are pretty smart at understanding when you are just trying to like to force a joke or some humor or some sympathy into them, and then kind of raises defenses. So you're going to get the opposite result. So yeah, also what Bruno was saying, yeah, go for what you feel, and because connecting doesn't mean necessarily just being funny. It means just level with people and behave with them as you would otherwise. You know, if you meet them, whatever you will meet them for a drink or whatever. So if you're someone that usually does jokes, yeah, sure, because that's going to be you. It's going to pass as you trying to talk to them, and
Exactly.
of course it's going to connect because you are also a person, probably.
If I may add something on jokes, I think we also have to be careful about the culture where we are, and the jokes can be different in different countries, and the perceptions of jokes can be different. I don't know, probably some. I noticed that here because when I first arrived, and sometimes I was making jokes that were funny in Italy, but were not funny here. So nobody would laugh, and I was feeling a little bit as a stupid. So that is something that perhaps we want to adjust if we change country. If we are in our own country, usually we can be free to be ourselves. We know it's not a big deal. I mean, we know if we were grown there and we know how it works and we know what kind of jokes that it's socially allowed to do it in public or not. When you change country, sometimes you have to be more careful. First of all, because you don't want to offend anybody again, and second, because sometimes it's just not funny. It's just a different way of joking, depending on the culture that you come from. So that is another thing I think I mean, that applies everywhere and in every kind of talks, probably, not only in science communication, every kind of social interaction. Yeah.
That's true.
Yeah, sometimes I have the feeling that people laugh just because they want to be polite, but they actually didn't understand a joke. So that is another thing. Well, in that case, you can be remembered as like, no, that funny person that was trying to make jokes that perhaps can let you pass the message anyway.
Yeah, you end up self-deprecating even if you didn't want to.
Yeah.
Any other comments, or should we continue kind of with the program? Okay, then we thought to make some slides, some presentation for like a science audience, and then the same thing for like layperson. So as I am a biochemist, I thought that I will talk very quickly about the cell and one of its organelle, which is the lysosome. So as we know, the cell is the single structural, functional, and biological unit of every organism, of every living organism. As you can see from the cartoon, the cell is made of an external plasma membrane, and inside there is the cytoplasm, where there are many, many different organelles, membrane-bound organelles that are important for cellular activities that all together make our cell work fine and efficiently. Today we will talk about the lysosome. I chose the lysosome. So what is a lysosome? The lysosome is a membrane-bound spherical structure that contains hydrolytic enzymes that are important to break down biological polymers such as proteins, DNA, RNA, lipids, and so on. So this breaking down is very important because it gives us all the building blocks that can be reused by the cells for further reactions. And so this was like just a very quick slide. So now I will talk about the same thing, but as talking to a really general audience that has no idea what is like a cell or a lysosome. So, okay, again, the same, the cell is like, I would use the similar words like the single biological and functional unit of life. We also talk about the cell as the building block of life. We can think in a way and compare the cells as to the Lego blocks. So a cell is a Lego block. So while with the Lego block, what you build is buildings, cars, and so on, with the cell, you will build life. So one cell will bring you to all the organisms that you see, everything around you. So the cell is made by an external envelope, and inside there are different structures. So it's in a way, I thought to compare it to an Easter egg. So there is a hard shell outside, and then inside there are many different tiny things, and all these are very important for the cell to function properly and to take out all the activities. To talk about the lysosome, I found this cartoon from 1986 that compared the lysosome to a dismantling recycling factory. So you can say that the lysosome uptakes from the cells whatever it needs to degrade, cellular cargo, and then it will crush it and breaking down with the help of little helpers that will then build and make tiny building blocks that then are given back to the cells for further reactions. So this was something that I kind of put up like as the two different slides, two different like audiences. So I will be happy to get any comment or whatever you feel like saying about that.
Anybody wants to comment, ask questions?
I think she illustrates something that's very interesting, which is that when you talk to someone, it's good to use concepts that they're used to. The fewer concepts you have to introduce, the better. So if you talk to other biologists, they know with all these organoids, organelles, whatever these things are, they know what, I'm not a biologist, I'm a physicist, so I'm sorry. I'm horrible with names. So they know what these things are. So if you want to explain something, you can use those concepts and they'll be like up to speed what we're trying to say. But with the general public, if you have to explain what those concepts are before you have to explain what lysosome is, you lose a lot of time. You have a lot of moving parts in the heads that they have to figure out how they work. Well, if you use this analogy with like the dismantling thing, they know what that is. They've seen that happen. They know that in their lives, so that makes it much easier to understand the concept they're trying to convey.
Yeah, I agree. That's what I was always told. Like, for example, for my PhD defense, I had to prepare my PowerPoint so that I need to make it understandable for lay people, like for general public, because it's open to everybody. So that was something that I used a lot there as well to make them understand, make comparison, a lot of animations and so on, because yeah, that was like kind of mandatory. So I really like using these kind of things that brings you back to something that for like lay people are very, very like normal, or like, you know, chocolate and Legos and stuff like that. So yeah.
Like on this example, it comes into my mind that whenever I did presentation to the general public, I was always trying to think whether I wanted in the end to have maybe these people consider studying biology, or whether I just wanted, you know, to give these people that will never go and study biology just a piece of information of something that I will need to talk about in the talk, you know. So, for example, if I would be talking with, you know, someone that is like a young kid or student and whatever, and maybe, you know, this person could decide in the future to go and study biology, then I will try to present this general concept in a simple way, but also in a way that tries to inspire that, you know, there's something hidden, there's something still to know, and it might be cool to go and study this kind of thing, to go and learn about these things. It's just that I'm not going to do it here. And if I do that with some person that, you know, is there because he wants to learn from someone that is doing science but would never go into science on its own, because, you know, maybe he's someone who's already 50-year-old and, you know, has his life and whatever, and doesn't want really to do science, then I will just try to, as you were saying, you know, do this kind of analogy that just give him a background, that let him understand, let he or her understand what this thing does without complicating too much the spiel.
I also think that if you have the chance to have hands-on activity, like the Lego would be great to show. Like, I don't know, I'm imagining an activity like where you can give it to kids, and you can just say, okay, here are the Lego, and build up something, and every kid will build up different things. And then you can say, see, so the Lego is like the cells, and you're building different kind of organism with the same unit. And so I think that's a beautiful example, the Lego, how to do that. Yeah.
Thank you.
Okay, so I also have a presentation which is pretty much along the lines of what you just said. But before, just to introduce myself, I'm a physicist. I'm a physics professor here in Brazil. And my thesis, my PhD thesis was on cosmology. It has absolutely nothing to do with neuroscience. And then for my postdoc, I started working on comparing anatomy. So the story about how that happened is a long and very weird one. I don't have time to relate it in now. But what I think I bring to the table, because I'm certainly not a professional science communicator, but what I bring to the table is the fact that I had to learn how to communicate with a very different scientific culture than my own. I grew up being a physicist. So when you have our own language, you have our own methods, you have our own ways of doing things, and the biology do things in an entirely different way. So I had to learn how to do that and how to communicate effectively with these people who essentially sound like foreigners. I mean, like we go into a different country and you experience a different culture. So I remember when I was asked to give my first lecture in the lab I was working, and I thought, okay, I'll start easy because I'm not gonna talk much about math, and I'm gonna just talk about the concepts. And then I start talking, and I just see people's eyes going like this, like, oh my God, what's this lunatic talking about? And no one understood a word what I said. I mean, it was completely incomprehensible to them. So that kind of, I went into kind of a panic then, because I thought I'll never be able to work on this field because I don't know how to communicate with them. So eventually I learned. So I want to really talk about how you can learn to talk with audiences that are very different from you, and what you have to have in mind to do so. So the first item on Tahira's list is the one I really think we should emphasize the most. Know your audience and tailor your presentation to your audience. And it's not just about being the scientists or the general public, because you may be asked to talk to scientists that are not on your field. Perhaps you need help from someone who is an engineer, and you have to convince this person not only that what you're doing is worthwhile and interesting, but also that in a way that they can understand. And also, it's not just about being more, to make the presentation simpler or more complicated. I mean, different audiences have different interests. And the first thing you have to identify is what makes this interesting to them. So sometimes, I mean, when I'm talking to physicists, I give you the exact same content, the exact same ideas. But when I talk to physicists, I say, okay, so we found this power law relationship, this mathematical relationship, and they show that this is scale invariance. And they think, oh, that's really cool. And then I talk to biologists, and they look at me, yeah, so what? What does that mean? And like, and the same thing happens the other way around. I mean, talk about ostracites, and Kami just jumps up and down. Oh, that's the most amazing thing in the world. You talk to physicists, they have the faintest idea what an astrocyte is. Why should they be interested in that? So I think those are things that you really have to have in mind. The example I want to use to illustrate this is something that I'm very interested in on my own research. I'm trying to describe the shape and the composition of the cerebral cortex, right? And you have to ask yourself, okay, so how do I describe this? And you have to describe it with certain variables. You have to choose which variables I'm going to use. So if you look at the cortex as a whole, you have variables like the number of neurons, the number of glial cells, the areas, the thickness, the volumes. And some of these can be related to others. So not all of them are independent from one another. Furthermore, if you, these are derived, and these are independent. But furthermore, you can also find empirical relationships between these various variables. Some of them you can explain using some modeling and mathematical theories. Some of them are purely empirical, which means that there are even further relations between these quantities that you don't really see at first. So the question is, how many degrees of freedom you need to describe a cortex? How many numbers? So what's the minimum number of numbers that you need to specify that this is a monkey cortex, this is a human cortex, this is a rat cortex? Now that's the problem I'm interested in. Now imagine trying to convey this problem and to explain why this problem is interesting and why you should investigate it to different audiences. So I gave here two examples. First, I would say how to explain this to physicists. And second, how I would explain this to the general public. So to a physicist, I would show something like this, perhaps not in one single slide. And I'm not trying to explain this to you, so don't dwell on the details. Now, what this said to a physicist is that the problem that I described before in terms of cortices and areas and cortical thickness and whatnot, is very similar to the sort of problem you face when you study thermodynamics, when you study, say, molecules in a box that are colliding among themselves and then generating various phenomena such as pressure and temperature and so on and so forth. And I talk about degrees of freedom. I'm talking about the various ways that a molecule can carry energy. It can move around, having kinetic energy. It can rotate, has rotational energy. It can vibrate. It can have vibrational energy. And we can then explain how the energy of the system is distributed about these various degrees of freedom. And then we talk about how these microscopic degrees of freedom that describe each molecule in a gas can in a way be put together so that you describe the entire gas with only a few numbers, such as volume, the entropy, the number of particles, and the temperature. So this is how I'd explain this to a physicist. And it may not seem natural to, say, a biologist, but it's very natural to a physicist, because those are all concepts that our physicists are familiar with. So they are like in familiar ground. And they can then make an analogy to a brain, to a cortex, and explain to themselves now why these problems are now relevant to me in a way that they can understand, right? So this is how a physicist would see it and how we would explain it to a physicist. Of course, to the general public, this just looks like gibberish. Not only they don't understand, they don't know the concepts that I'm presenting here, but they don't see the point. And that's perhaps the worst thing. People, if they don't see the point of what you're doing, they lose interest very quickly. So we have to say to talk about something that they can touch and perhaps experience. So imagine you want to build a shelf, put your books on top of, okay? And how do you build a shelf, right? In particular, how many degrees of freedom you need to specify to build a shelf, which means how many components you need to put on the shelf so that it's stable. And that's what I mean by stable. Imagine that these are like the hinges or the nails that are part of the shelf. And each nail, in principle, can move in this two-dimensional space. So you need two numbers to specify each nail, right? They can go left and right and up and down. Now, that's not good, right? Because I don't want a shelf to be a bunch of things that can move around freely. So what I need to do is to start putting planks, put lengths of wood between these nails so that the distance between the nails are fixed. And for each plank that I put a further constraint on the shelf. If you put a plank, you fix the distance between two nails. If you put 4 planks, now you fix the distance between all the sets of nails. And you can ask yourself, is this shelf stable? Is it? If I put books on top of it, will it stay put or will it move about, wobble, or fall apart? What do you think?
Stable.
You think it's stable? Okay, that's the thing, it's not. And the beauty of it is that you can use the math of very simple math to show that it's not and why it's not. So what happens is this, it can wobble. It can do like this and go back. Sorry. Yeah, it can do like this. So it can wobble. Now, why is that? Well, the reason is that all these configurations where these things like a losange, it's like a parallelogram, they all obey all the constraints I put on the shelf. And still the shelf moves about. So to make the shelf stable, I need a further constraint. If I put a diagonal plank like this, now it's stable. If you buy one of those shelves, metal shelves that you can build for your lab, you see that they always have this diagonal band exactly to make this stable. And how can you show that it is stable with this configuration? Oh, all we have to do is count how many numbers you need to specify, 8 numbers, right? 2 for each nail, and how many constraints you have. So what happens is this. I have 8 numbers I want to specify, but 2 of them are simply the position of the shelf itself on the horizontal line, on the vertical plane, right? Vertical and horizontal. So I have to explain 6 numbers, but one of them is just the rotation of the shell as a whole, which is not something that I have to consider. So I have to explain 5 numbers, right? Which means that I need 1, 2, 3, 4, 5 constraints. So that's why 5 planks will make a shelf stable. And the same analogy applies both to the same explanation applies both to the molecules in a gas, to the various variables that describe a cortex. So it doesn't seem to be, but we are talking about the exact same thing. And for different audiences, we use different concepts, but we try always to end up in the same place. How many numbers you need to specify to make sure that you talk about a monkey brain, a human brain, a rat brain, or elephant brain? Or how many planks you need to put to make your shelf not fall apart. That's the same thing, right? So that's the idea that I want to illustrate with this like long detour through physics, biology, and shelf building. We have 2 times 4 numbers for the nails, 5 planks, 1 global rotation, 1 global translation, have no further need to specify anything, and therefore the shelf is stable. And of course, you can generalize this, and that's how you build robotic arms. Each joint is a degree of freedom, and you specify the numbers for each joint to describe the position of a robotic arm. You can build cars and robots and space stations and Death Stars and whatever you want. So that's it. Okay, so that's what I wanted to say about communicating to different people using different concepts and different ideas. So does anyone have any comments, some questions, or want me to stop talking and they have a headache? I don't know.
I think it was a beautiful example, Bruno. Thank you. There was a conversation in the chat going on about IKEA in the meantime. we don't think IKEA sells very stable furniture.
Well, yeah, they should hire more physicists. They should always hire more physicists. So,
I think, sorry. Yeah, one of the difficult things I find to balance when talking to a general audience is how to simplify without oversimplifying to the point where you're no longer telling the truth. about something. So I don't know if anybody has any tips on that, like how to find a way to stay truthful to the work and still keep it simple.
Yeah, that's a very hard question. I think, I mean, sometimes it works to change subjects in a way, like I did here, so that I'm still talking about degrees of freedom, but on a much simpler, a much more commonplace experiment than the ones we start talking about. But sometimes it's unavoidable. If you want to talk about quantum mechanics, and that's like a perennial problem with this, we're talking about stuff that is intrinsically different from what you're used to. So some level of simplification, some level of incorrectness must creep up somehow. And I think you should just be honest about it. You should say, okay, this is an oversimplification. It doesn't convey the entire complexity of what I'm trying to say, but that's how I can say in a way that it can be understood to people who don't know all these other concepts. But there's no like fixed answer for that.
Yeah, I agree. Like you just try to be as honest as possible with your audience, and like whatever comparison you make, then like as long as you like, you know, give the message and try to be like as open as possible with the audience, I think. Yeah.
Maybe, Melissa, one thing that should go before this step, this kind of question is, whether you want, it's trying to understand what exactly you want to tell to your audience and why. Because of course, let's say if your goal is to try and explain completely your thesis to, I don't know, 10 graders, then yeah, it's going to be complicated to do. But before doing that, maybe you ask yourself, why should I do that? And is there maybe just another message that I would rather give in this, I don't know, maybe 1 hour or short amount of time that you might have if you have this kind of interaction? Because maybe there is another kind of story that relates to you and to your science that you could give to these people, and it would be equally as engaging, if not more. And this I'm talking from direct experience, because when I was starting to do this kind of events, when I would talk to people in school, yeah, the first thing that I was thinking is, should I really tell them about my research? I mean, it's kind of boring. Why should they tell them exactly what I've been doing in my thesis? Maybe I just know something that is, a little bit more interesting. There is a bit more of intrigue or open questions and so on. And I found that actually a little bit more engaging than just telling me a short version of my thesis or whatever.
Elia, I'm so glad you mentioned this, because sometimes I feel like I'm cheating when I select the topics that I want to convey to the audience, because I do the same. Sometimes I choose the topics depending on the audience, and I don't know, if I'm speaking to schools, I'm never going to speak perhaps about like tiny molecular mechanisms, I don't know, in evolution. So I'm going to stick with more simple questions.
Yeah.
And also I think because that's our mission as scientists, to give like some scientific ideas, to convey some scientific ideas that they don't have yet, or to induce some sort of curiosity. So it's not always about communicating our science. It's not about ourselves. It's more about what we want to induce in the public. So but I'm happy that you do the same, because I was feeling like probably I should like do always my research and not like
I'm experiencing the same, because I'm preparing a short talk for my institute, and I had to choose a topic that I can present in a simple way to a like audience that is not only scientific audience. And so I have to explain all the trafficking of the nanoparticles towards the tumor. And since I was thinking it's too complicated and explain all the proteins involved, all the pathways, and etc., I decided to do a parallelism with mythology. And I decided to use the Odyssey as a way to explain all the roads that Ulysses has to cross and obstacles has to face in order to reach Ithaca and come back home. In the same way, our nanoparticles has to find a way when they arrive in the body to understand where to go and reach the tumor, or reach the target site. I mean, it was just an example because I'm working on tumors. And so I hope that they will like it, because it was very difficult to find a connection to explain I mean, the trafficking of the nanoparticle in a simple way. So I said, okay, maybe the Odyssey and the journey of Ulysses can be a good option to make it a little bit funny and more interesting, not speaking only about science. So maybe what I'm saying is that the message, the scientific message will be, I mean, not super specific or super scientific, but at least maybe I can render it like more interesting for a broader audience, something like this. So sometimes maybe find a nice parallelism or connection with, I mean, other fact, historical fact, or whatever it can be helpful. This is my experience. I don't know if it will work. I will tell you maybe in the next meeting.
I love
Tell
the
us next
idea.
week.
Yeah, Federica,
Me
I think
too.
it's a great idea. I love it. It's so beautiful.
Thank you, thank you.
What I wanted to say, it's I think we mentioned this, but it's like in some way we do science communication because we need to give back to the society what they gave to us, and they're not going to be able to understand our scientific papers. That is a fact. But I also think that there's one part that it's important, and it's that this pandemic and everything, I think it was a very clear example of how bad we're doing this as scientists. And I'm sorry to be that clear and that mean, but there were a lot of other messages around that were confusing for them, and people don't trust scientists as much anymore because they cannot understand that, and we have not been able to putting ourselves there, putting our research in there, and we are failing. So we need to do better. We have the responsibility of doing this more often and doing it better, so people can understand how science works, and the people can understand how scientists work, and they are not lying to them, and they are not, I
And
don't know.
trust us. Yeah.
Exactly.
Trust
I don't
us.
know if
Yeah.
they always call out the pharma industry and how we are all bought by them. I am still waiting for my check because I never received one, and it is somehow it's a joke and not at the same time. I really feel like responsible from that point of view, and I think we are failing. And there's now, I don't know if you saw this documentary on Netflix about people believing that the Earth is flat again.
I haven't seen.
It's
Yeah.
very interesting. It's very interesting because these people are like, they believe they're using like scientific principles, and there's like a conspiracy to make us believe that. It's not they are like stupid people thinking stupid thing. No, they are just, they are not trusting anyone anymore, and that is an example of how we are failing in delivering to society what they need to know.
Mhm.
And they feel that the science is going at a certain speed and they cannot follow us. So I think we have that responsibility, and it's just like this thought about that, about how we should really engage in doing this in a way that it's easy for them, and they don't make them feel stupid, as we were saying before. We don't want to make them feel stupid. No one likes to feel stupid. If you do that, it's going to be very likely they're going to prefer the people telling them that the earth is flat instead of you. So
Sana, like on the other hand, there is I remember there was a documentary by Al Gore, and it's in Netflix. It's classified under conspiracy theory, and I'm like, no, that is not a conspiracy theory. That is the truth. So it's a little bit messed up. Yeah.
And it's scary, actually, if you think about it.
Yeah.
Like, I mean, yeah.
Sorry, Bruno, you were saying something.
Well, no, I was just saying that one problem sometimes I have, I mean, I don't know if that's universal, is that sometimes I fall in love with my own research. I mean, there's this like, I mean, it's like everything you put in your thesis, it's like your children, right? And you don't want to leave them out. I mean, you don't want to leave like, I don't know, little Marquinhos out of the story, because I mean, how is going to feel with all his siblings are going to be presented and he's not. So it's really hard to like leave things out and just leave the essential, but that's a very important thing to do, because you always overestimate your ability to explain complicated concepts, and you overload the presentation 20 of them, and you think, oh, just like a short sentence in the beginning, and they don't understand what you're talking about, but they won't, because they're still thinking about your previous slide, and you try to talk about 5 other things in the next one. So try to talk about fewer things in greater detail is usually far more effective than trying to cover everything, even though you have to leave some really beautiful stuff behind. Another thing, referring to what I think it was Melissa, no, Carmen, what Carmen said, the other Carmen Munoz, said about the presentations. I mean, one thing that people really get engaged with is talking about the process of discovery, not just what you found, but how you found it. And you can talk about the dead ends and things that didn't work out, right? And that is very good to give people some perspective of first the amount of hard work that it takes to do research, but also the significance of it. Because they know, okay, what was your question before you found these things? And why, what inspired you to search for these things? So explain things in terms of a scientific process, even if you talk about things that went wrong, I think it's sometimes a really good way of presenting your research rather than just presenting things as done and fixed body of facts that you just have to impart.
Yeah, I feel that you're right. Sometimes like explaining, like you were saying, the human side of the scientific processes is also very impactful, because I remember sometimes some of the most effective presentations, they were like people like explaining me, yeah, and then I couldn't sleep at night while I was doing it, or like giving some sort of backstory
Background,
to the,
yeah.
yeah, to the scientific process, or and then this experiment didn't work and why it didn't work, and how I was feeling, so that if like they feel like you're human, like Elia was saying, hopefully. So,
Yeah,
uh,
hopefully, the best of my knowledge, yeah.
so
It
yeah.
hasn't been said otherwise yet.
Yeah, I haven't seen proof of it yet.
We should investigate.
I also like to say this example about even making mistakes in science is impactful. And the Italians are going to hate me, but I always put the example of Golgi and his reticular theory. There was like this debate between Cajal and Golgi. So Golgi thought that the neurons were actually touching each other, but Cajal thought that they were not touching each other, and it was through the synapses. They were like they were like releasing stuff, and they were not in contact physically. And they both win the Nobel Prize at the same time, but only one of them was right. And it was Cajal, by the way, that was a Spanish guy, not the Italian guy, just in case you don't know. But I like to tell the story because you can be wrong, but still make such a big impact in the field that you still are going to be acknowledged with that. So even mistakes are it was right for us, was fine. Yeah, I mean, we can talk about that in another moment. But yeah, the thing, Melissa, in case you don't know, Cajal did his PhD in scar forming, glial scar, and all these kind of things. So that's pretty cool, actually. But no, but the story is that making mistakes also moves the science along, and help us to understand better things, and also make big impact. So yeah, I don't want to have like this fight against Italians and Spanish, because I just discovered that the inventor of epidural, that it's an amazing thing, was Spanish, but an Italian read his work and took the credit for it, and later it had to apologize because there was this Argentinian guy that already real say, what are you saying, Italian guy, because the other one died in the car accident. So yeah, don't start this fight. I love you, Italian guys. No, that's just a joke.
For those of you that doesn't know, Carmen is married to an Italian, so I think they're having this discussion all the day.
Yeah, that's exactly why I look for all this information,
So I think it's almost time to wrap up. And Tahira, you wanted to talk about the different channels for science communication?
Yeah,
So that we can introduce all the future sessions too.
Yeah, so I think the comment was just that probably most of the time people think that it's just, giving talks or giving poster presentation, but actually kind of there has been a lot of development in science communication, and we use like blogs, Twitters, or podcasts, or like many things. So this was like a good connection for you all to let you know that we will be discussing about all these things in the upcoming sessions. So please stay tuned and follow us on Twitter so that you will be.
So I can do like a brief recap of what's coming. Yeah, just because I have the schedule, I don't remember all of them. But I have. So next week, Jake will share an event on blogs, and we will have to invite speakers to bloggers speaking about science communication through blogs. And then Rebecca will show us on November 17 on how to make videos for science communication if you want to prepare. So like technical things, how to make a video. So that would be very cool too. And I don't know if you want to put a video then on YouTube or whatever is your website. I think it's also very nice to have video skills preparation. And then Bianca will share an event on how to organize outreach events, like in-person events, when this will be again possible. The in-person events are also very effective in my experience, like all the hands-on activity, or when you invite guests and you speak to an audience like face-to-face. So that is another thing that she will explain. And we will co-host an event with scientists. I don't know how to say that, but so on networking and social media engagement. So we will speak about science communication through social media. And then Michael will speak about social construction of science, and this will be a bonus event in the end of the the second edition of BioRoom. So this is going to be what's coming next, guys.
A lot of cool
I'm very
stuff.
excited. Yeah, and thank you very much, Tahira and Bruno. And unless anybody else has some final comments, it's the first time we are on time, and I don't know what happened today. You were great there. So thank you again. Thank you all for your participation. And I never thank Elia enough, but Elia is our video maker, video preparator for the YouTube channel. So he's been helping a lot about that, and he's also co-organizing this. Today he was cutting at the cryostat, that's why he was with his camera off. Okay, so see you next time. Have a great day, night, or whatever.
Bye, thank you.
Bye.
Thank you for everything.
Bye. Bye.